Okay guys, so in this video we're going to be talking about how to solve literal equations. So literal equations is just basically fancy math talk for a formula, and then solving literal equations is basically fancy math talk for rearranging formulas. So all we're doing when we're solving literal equations is basically making formulas look a little different. So the steps to solve literal equations are the following. First, we got to identify the target variable by either boxing or highlighting it. So if you don't have a highlighter, you can put a box around it. Whatever you need to do to make sure that that variable stands out. Next, you need to draw the wall, and then you want to move every other variable to the other side of the wall. You always want to start with the ones that are furthest away from the variable on the same side. That way you can move everything to the other side except for that target variable. I'll do some examples for you guys so you guys can see how to solve the literal equations. So example number 1, we are solving the literal equation for variable d. So again, the first thing you need to do is identify the target variable, so make sure it stands out. So I'm going to go ahead and draw a box around it with my red pen. That way it stands out. So I want to get the variable d by itself. So how do we do that? So there's different ways of doing this. First of all, we need to identify the target variable. Next step says draw the wall. So we want to move everything to the other side except for D. So I want to get rid of the C and I want to get rid of the 2. The question is, which one is furthest away? And if you guys said C, well, that would be incorrect because there's actually a wall that's separating the C and the D from the 2. So the 2 is actually furthest away because there is actually a wall separating it from the D. So it's not even on the same side. So I'm going to go ahead and start getting rid of the 2 by doing the inverse operation of the 2, which means to multiply. Right? Because if it was divided by 2, we want to do the inverse of that, which means to multiply by 2. So if I do that, if I multiply this side by 2, then the 2 and the 2 cancel out. But I can't just do that and not do the other side because we got to keep the equation balanced. So I have to do the other side by 2. So that'll be 2 multiplied by q on this side. So let's rewrite this real quick. So we have 2q is equal to c plus d. So again, the whole point of this is to get the d by itself. We want to leave the variable alone. So c and d are being added, so we want to get rid of the c now to get the d by itself. So we want to do the inverse operation of whatever is going on with the c, which in this case is being added. So we're going to subtract c to this side so it can cancel, and then we can get the d by itself. And we're going to do that to the other side as well, subtract c from this side. So again, in these problems, we're not going to get a nice answer or a nice number. The whole point is rearranging a formula. So at the very end of the problem, same as the beginning, we're going to get a formula. So 2q and c are not like terms, so don't think that those two can go together in any way. So the final answer will just be 2q minus c. You just straight up write it out. And this will be your final answer. So when you get the d by itself, when you solve for d, the expression that we get, or the formula that we get, is 2q minus c. And that is it. So again, you're rearranging formulas for this. So don't freak out if you don't get an actual answer, like a number, because you won't get a number. Okay, example number 2, we got to solve for the variable pi. So pi is this symbol right here. And I want to get rid of the b squared and I want to get rid of the c. So I could draw the wall, and I want to move the b squared to that side and the c to that side. How do I do that? Well, these guys are all multiplied together. In an earlier video, I told you guys that if you guys have a variable or variables together like this, stuck together, that means that they're multiplied. So if you want to get rid of them, all you have to do is the opposite or the inverse, which is to divide. So if I divide this by b squared, the b squared would cancel. But wait, I don't just have to move b squared, I want to move c as well. So let me just divide this by c as well. That way this can cancel. So there you go. So if we do that to this side, then we have to do it to the other side. So we get b squared c. So we have the pi by itself on the right side. So we are technically done. Pi is equal to a divided by b squared c. So there is our formula, or a literal equation. Okay, example number 3. I'm going to do a few more examples because I know this is the part that a lot of people don't like. They freak out when they see formulas, and I don't know what really goes on in their mind, but hey, I'll do more examples so you guys can not freak out as much. Solve for t. So again, the t is down here. So I'm going to make a little box around it so it can stand out. Notice that we have a fraction on one side and a fraction on the other side of the equal sign. Does anybody remember what do we do in that case? If you remember one of the earlier lessons, it was to cross multiply. So if you multiply this times that, and you multiply this times that, you actually get rid of the fraction, which is really nice because you don't even have to deal with it. So v multiplied by t will be on one side. I'm just going to write vt. 3k multiplied by 1 will be on the other side. 1 times 3k. And let me just color code this so you guys can see where they came from. Okay, so we have this. But again, if you don't box your variable, it's going to be really confusing about what the heck is even going on. The whole point of this problem is to get the t by itself. So we're almost done, right? We just got to get rid of the v. The v and the t are being multiplied, so if you want to get rid of the v, we just have to divide. So if you draw the wall, divide this side by v, this goes away, divide this side by v, and we are done. The expression for t, or the literal equation, is going to be equal to 1 times 3k, which is just 3k, divided by v. Alright, so let's upgrade to the next level here. So let's do some big boy formula. So these ones look a little crazier, but let's use the same process that we did before. So we want to solve for w. So same idea. So we are going to box a w. Notice that you have a fraction on one side, fraction on the other side. So I'm going to just take advantage of that and then say that I'm going to cross multiply to get rid of the fraction. So multiply these two together, multiply these two together, so we don't have to deal with fractions anymore. So on this side we're going to get p parentheses means multiplication 3 plus 2w, and that came from the stuff that I colored in pink. So let me just recolor it real quick. And then on the other side of the equal sign I'm going to get 1 times 2, which is just 2, and that came from the stuff that I colored in green. So looks a lot nicer, right? So next thing we need to do, since you have a term on the outside of the parentheses, we have to just do the distributive property to simplify. So this is going to be multiplied with this and this. So we're going to get 3p plus 2pw. So multiply, multiply. And then that's going to be equal to 2. Okay, so I boxed the w to let me know what it is that I'm doing here. So I'm trying to get the w by itself. Again, we're trying to move everything to the other side except for w. So notice that I got to get rid of the 3p and I have to get rid of the 2. Which one do I start with first? Well, you always start with the one that's furthest away. 2p is right next to the w, so I'm not going to start with that. I'm actually going to start with the 3p over here. So we're going to be subtracting, because this is added. Notice that there's a plus 3p on this side. So to get rid of it, you have to subtract, inverse operation on both sides. So subtract 3p, we get 2pw on the left-hand side is equal to negative 3p and 2. Wait a minute, they're not like terms, remember? So don't try to feel like you're going to be adding these two, because you can't. If you can't add them, you can't add them. No big deal. So this is actually going to become 3p plus 2. Almost there. The whole point is getting the w by itself. So last thing we need to do is get rid of the 2p. 2p and w, they're stuck together. That means that they're being multiplied. So we have to divide by 2p on this side so it can cancel. Whatever we do to the left, we got to do it to the right. So we are done. Our final expression for w, or final formula, is w is equal to negative 3p plus 2. And then divide all that by 2p. So negative 3 times p plus 2, and then divide everything by 2 times p. All right, one last example. So the last example is basically a formula for area. This is actually the area of a trapezoid. It's a height multiplied by base 1 plus base 2 divided by 2. So the whole idea here is trying to get the b2 by itself. So we want to get this guy alone on one side. How do we do that? So it looks different than the one we did before, but we could actually make it look the same. Notice that I put the p over 1 on this one. We could do the same thing with the area one. So we could always say that this is a fraction on one side and a fraction on the other side by putting it over 1. We could always do that to take advantage of the cross multiplication rule, which means that if I have one fraction on one side, fraction on the other side, I could just cross multiply to get rid of the fraction. And I will do that to the whole entire thing. So Simplify 2a, 2 times a, that'll give me 2a. 1 times all that stuff, that's just all that stuff all over again. So b1 plus b2. So this came from the pink stuff that I colored. And then when I multiply 1 times all that, well, the 1 doesn't really change anything when you multiply, so it just becomes h parentheses b1 plus b2. Okay, almost there. So distributive property, we have an h on the outside of the parentheses, so we're going to multiply everything by the h. On the left-hand side, it stays the same, 2a. On the right-hand side, we're going to get h times b1, which is just hb1, and then h times b2, which is just hb2. So if you just stick the variables next to each other, basically it means the same thing as you already multiplied it in multiplication. So almost done. We got to get rid of this guy. We got to get rid of this guy. So get rid of the hb1, get rid of the h, move it to the other side, so we can get the b2 by itself. Which one is furthest? So that one's furthest. So we're going to start with that guy. Opposite of plus hb1, we have to subtract it. And then that way it'll cancel out on this side. We do the same thing to the other side. Minus hb1. And then we're almost there. So 2a minus hb1, we can't combine those two, so I'm just going to rewrite it longwise. And then that's going to be equal to that stuff on the right side, which is hb2. So we get that is equal to that. Almost done. So we just got to get rid of the h now. And it looks very familiar, right? So if you want to get rid of the h, we have to divide by the h because it's being multiplied right now. So divide this side by h, that goes away. And divide the whole entire left side by h, and we get an expression for b2. So my final formula for b2 is actually equivalent or equal to 2a minus hb1 all divided by h. Okay, I hope this video was helpful on solving literal equations. See you guys in class.